Hello, and welcome to today's lesson on real and virtual images. Today we will cover real and virtual images and their distinct characteristics. So far, you are familiar with the features of lenses and the characteristics of convex and concave lenses, which will help us understand how these lenses form different types of images. Real images are formed when actual light rays converge at a specific point after passing through a lens. To understand this further, consider using a convex lens, which is also known as a converging lens. When parallel rays of light pass through a convex lens, they converge at a point called the focal point. If an object is placed outside the focal length, the distance from the lens to the focal point of a convex lens, the light rays from the object will converge after passing through the lens to form a real image. Real images can be projected onto a screen or surface because the light rays physically meet at a point where the image forms. These images are always inverted, meaning they appear upside down compared to the object. For instance, if you place a candle in front of a convex lens, the flame will appear upside down on a screen placed on the other side of the lens. Additionally, real images can be captured by a camera. In photography, the camera lens focuses light to form a real image on the film or digital sensor. Let's bring this to light with an example. Movie projectors. Movie projectors use convex lenses to project real images onto a screen. The film in the projector contains an inverted version of the image. The projector's lens inverts the image again, resulting in an upright image on the screen. This double inversion allows us to see the image correctly. Virtual images are formed when light rays appear to diverge from a specific point after passing through a lens. However, these rays do not actually converge at that point. This is typically the case for convex lenses, when the object is placed within the focal length, as opposed to being placed outside of the focal length. Concave lenses also create virtual images, but unlike convex lenses, are not able to create real images as well. Virtual images cannot be projected onto a screen or surface because the light rays do not physically meet. They only appear to come from a common point. Additionally, these images are erect, meaning they appear upright compared to the object. For example, when you look at yourself in a flat mirror, the image you see is upright. A common flat mirror produces a virtual image by reflecting light rays. The light rays seem to come from behind the mirror, creating an image that appears upright. You cannot project this image, but you can see it clearly. Similarly, when you use a magnifying glass to enlarge text, the lens forms a virtual image of the text. The light rays do not actually converge to form this image. If you try to project this enlarged image onto a screen, it won't appear. The image remains upright and only appears larger when viewed through the lens. In today's lesson, we distinguish between real and virtual images, fundamental to understanding optics. We learned that real images are formed when actual light rays converge at a specific point, after passing through a lens, resulting in images that are inverted and can be projected onto a screen or captured by a camera. Conversely, virtual images form when light rays appear to diverge from a point without actually converging there. These images are always upright, cannot be projected, and cannot be captured by a camera. Convex lenses can produce both real and virtual images, while concave lenses only generate virtual images. Understanding these differences is crucial for various technological applications and helps in solving optical problems that involve lenses and mirrors. Watch the rest of the GCSE Physics course at Sophos Education.